All right. Hi, everyone. Thank you for giving me the opportunity to talk to you. Sad I could not be there in person. Really excited about the OC3 conference. Been involved with this group for a while now, so I'm very happy to have a chance to speak to you again. So today, what I'm going to talk to you about is what advancements have we done in Azure Confidential Computing. And rather than focus on a particular sort of area, I'll kind of walk you through what innovations in real world applications that we have seen in confidential computing so far. So my name is Vikas, and I'm the head of product for Azure Confidential Computing here at Microsoft. Next slide. Okay, so what I'm going to walk you through is three sections. One is how has security evolved in Azure over these years? And then I'll talk about a few innovations in our space and state of adoption. How are people using confidential computing today, both inside and outside Microsoft? And if you've been around Microsoft, you know we have this term called dog fooding. How are we dog fooding our own products? So first, let's talk about how are we thinking about Azure security overall. So if you're not familiar with Secure Future Initiative, or SFI as we've been calling it, this is a massive investment at across Microsoft, across 35,000 plus employees, where we have taken a serious look at security. It's a complete end-to-end view on security, where we are focused on secure by design, secure by default, secure operations, and it's really around multiple vectors. The first vector, which is really the most important one, is how do we protect our identities and secrets? I'll get to that first one later. And then there's multiple things happening and not limited to what's on the screen, but it's around, protecting tenants, protecting networks, engineering systems, providing responses to events as they show up. But really, it's about culture in at Microsoft. It's a security first culture that we've been pushing for across our employees, across our product stacks. Security first, followed by features. And since this is confidential computing, I'm sure you'll see this slide multiple times in different flavors in the conference. But confidential computing, as we all know and love, it's about protecting data and use. And the second thing is, given that we have confidential computing, we now have end-to-end data protection from the time it's created until it's destroyed. Worth bearing in case there's somebody new to the conference. Now, Microsoft has been in the confidential computing space for a while now. In 2014, we started, Microsoft Research in UK, Cambridge. When we formed the first research team, we published the paper in 2015. The Confidential Computing Consortium was one where we were instrumental in co-founding that with our partners. But along the way, we've had multiple releases in, first with Intel SGX, then on AMD, and then on containers, on Intel, on NVIDIA GPUs. Along the way, we've constantly been, innovating in the space of confidential computing, right? And it's been a long journey. It's a 10 plus year journey so far, and there's many more years ahead of us. But really, this is sort of what it takes to bring something so innovative, so game changing to the broader market. And we have been making a ton of progress in our portfolio, right? And this is not a comprehensive list, and it kind of keeps changing all the time. But generally, the way we kind of think about it is, we enable these features in silicon with our silicon partners, enable the virtual machines, the containers, and start bringing up the services that need to be confidentially enabled, running in a confidential environment. Some of the things that are around that I'm going to cover is confidential inferencing with Azure OpenAI, Whisper models. We also see a ton of interest in confidential Azure desktop. We've been working with Databricks and a confidential Databricks offering, as well as with our partners in Azure Red Hat OpenShift. And many of our services are also, becoming confidential over time, as physics allows, and so on and so forth. So that's sort of setting the stage on, how do we think about security in Azure and how it has evolved over time, and really how the confidential computing space has evolved over time. So what I'm going to talk about next is what sort of innovations are we pursuing in confidential computing right now. So the first thing I'm going to talk about is Azure Confidential Clean Rooms to enable these multi-party collaboration scenarios that we know are a unique use case that confidential computing can help solve. So if you're not already familiar, we know that there are challenges with processing, sensitive multi-party data. A lot of them have to do with, privacy and regulations. We've been talking to a bunch of customers on how they are leveraging confidential computing for ensuring compliance with regulations like GDPR, HIPAA, etc. We know a bunch of customers who are doing this. Now, we also know that there are issues with sharing data. How do you share data without sharing data itself? Because when you're sharing data, you assume that the other party is not going to do malicious intent or take that data, but there is always this fear of losing control over the data once it's shared. So what I'm going to talk about is, okay, what is this multi-party collaboration? So this is about multiple organizations, two or more, to who want to share data, uh, process the data in an isolated environment, and get that insights back to the organization, so that they want to make sure that they have the ability to move their business forward, but at the same time not lose control over the data that they're using to in order to get their business information out. So let's go through the first demo. Can you please tell me online if you can hear the audio as well?
Fabricam, a furniture store chain, wants to collaborate with Contoso, a data analytics firm, to create a targeted advertising campaign. Both collaborators are concerned about sharing their private data. Confidential clean rooms can make this possible with privacy-enhanced data collaboration.
Okay, so no audio. So let me kind of reset this a little bit, and let's start again. And maybe mute this guy if there's a
Fabricam,
Okay. So what's happening here is, there are two organizations who want to share data with each other, right? They want to launch some sort of a ad campaign here. And so what they're going to use is these Azure Confidential Clean Rooms that we built, for our ISV partners as well as our customers. So what's happening here is Fabricam is setting up the confidential clean room in their tenant. Contoso could also do it, or they could be an additional party that does this. So what you get here is you got these tamper-proof contract and queries that are going to be set in policy, which allow you to say, okay, how is my policy going to be executed? You have really good control over your blob storage, how your data gets accessed. At the same time, what you're doing is you're agreeing with your partners on what sort of contract and queries that you're going to do. And the most important thing is how you're going to protect your keys. We have secure key release policies that we've already enabled for confidential computing. And the other thing that you do get is sort of this tamper-proof audit logging capability that allows you to know, okay, how has the data really been accessed in this multi-party situation? So as you see in this demo here, you've got this contract executing. You've accepted this contract, if you may. Um, and your query has successfully executed a query that you predefined before and agreed before that this is how it's going to work. And the output here is sort of what you had agreed before, that this is the only thing that comes out. It's a allowed output based on predefined agreements that you had as part of the policy. So this is something that is in preview right now. I need to figure out how to share the audio. If somebody in the audience can type it in the chat, maybe the next time I can kind of share the audio, because I've got two more demos to go through. So this is in preview right now. We have it on our website. Please sign up and let us know if you're interested.
Fabricam.
So as I mentioned earlier, this is the logical diagram really of how it works. It doesn't matter which organization is running the clean room, but it's running inside the organization's tenant. You might have a third party tenant that can, so the audio did come through, Mark. Okay, great. So it doesn't really matter which organization is running the clean room, as I mentioned. But what you have now is more control over what you can do. And I know we've been working with many of our ISV partners to enable confidential clean rooms on Azure. And this is our approach to kind of help our ISV partners as well our customers to deploy into Azure, and providing these clean rooms as a first party construct that enables acceleration of these workloads to happen with confidential computing. So the next thing, let's talk about confidential AI. So why do you need confidential AI, right? I think the place where we are in this AI revolution that we've been seeing, we know that the model weights are the most important asset that really the model provider has. With confidential computing, you can protect the model weights. Along with that, any prompts, training, any sort of data that goes through to the model is something that want to be protected. And the other thing is, like the scenario that I just talked about before with clean rooms, you can also enable new scenarios such as multi-party data sharing with confidential AI, which is something that we've been hearing a lot about from our customers. So we've had confidential GPUs with NVIDIA available in general availability for a while. These are available in East US 2 and West Europe. But if you're familiar with a confidential VM TEE, right, what are you really trusting in that TCV? So on the confidential VM, you have a virtual machine, which is a confidential virtual machine, and all you're trusting is the application and the code that you're bringing to the confidential environment, and you're anchored off that root of trust that is, anchored in the hardware root of trust from the CPU. What we've done with confidential GPUs is extended that trust model into the GPU memory. So when you have HBM or high bandwidth memory, and your model prompts, your model weights are running inside the GPU TEE, that stays protected as well. And you, as the developer, can individually attest the CPU TEE as well as the GPU TEE, and also every communication that's going back and forth between these two architectures is going through the PCIe bus, which is also encrypted. So here, what you have here is your TE extending into the GPU and enabling and making sure that it is end-to-end encrypted. Now that's great because it allows you to do, your GPU confidential virtual machines. But this also extends into interesting areas with confidential LLM and RAG scenarios with retrieval auto generation. So as an example, you might have some sensitive data that is encrypted in your on your side, and you want to give it to a confidential GPU VM, run it in a vector database, provide some input, run it against an LLM, and get that output out. So as you see in this picture, the whole end-to-end is encrypted as well. So let's go into the next demo, which is about, okay, how are we doing these RAG scenarios? So on this one, there is no audio, so I'll walk through it. So some of you who've been around here must have seen this before. But what we've done here is provided an extension. Again, you don't really need an extension. It's just to help with the demo. But what you're doing here is you're creating a trust relationship with a particular website, right? And you're setting up the attestation policy both on the CPU and the GPU. And I'm going to save this and ensure that it is now this website can be trusted, right? And the website is only trusted once the attestation passes. So here we can see back in the extension that my CPU attestation claims have passed, my GPU attestation claims have passed, and now I can trust the website that this is actually something that I can interact with. So now I ask the model, okay, what is confidential computing? I don't know where this model was formed, but it doesn't know it. It needs to learn something. So I'm going to give it this particular document, which is a PDF document, which again goes into that vector database. And now I can see that the data has been added to the vector database, the RAG database here. And now if I execute the query again, you would see that the model has learned, it has that database to kind of turn to, and now it can give you some more information. Now we know that RAG is a pretty critical use case for all of our AI workloads that we're running with. Now RAG is also important because you're dealing with sensitive organizational data. So now I think what we're trying to do is we're going to make the attestation fail because we are changing the driver version, behind the scenes. Let's save that again. And here you'll see, okay, the driver version failed. The attestation will fail because you were expecting a different driver version than the driver version that you got, right? So this also shows you the fail condition for how confidential computing will help you um, uh, enable these sort of RAG scenarios. The other thing that we've done is, confidential model as a service with Azure OpenAI. The first model that we're providing with model as a service is the Whisper model. So if you're not already familiar with Whisper, it takes the audio and transcribes it. So here, what we have is we've enabled these oblivious HTTP proxies from the enterprise side. And on the cloud, when you're coming, you're going through the Azure AI OpenAI front door service, and the OHTTP gateway is obfuscating sort of where these requests came from. The Azure OpenAI Whisper model is running inside the confidential GPU VM, and you have the end-to-end, key release, secure key release happening here, so that the Azure OpenAI service is also included in your TCB, but it's making sure that you're not uh, leaking your security in any way. So the other demo that I have right now that I'll walk you through is how we're doing this with Azure OpenAI. And I'm hoping Antoine is there in person because there's this picture right there. And so what we're doing now is we have this Whisper model that you can't hear it, but I can tell you what it's saying is
future of cloud is confidential.
The audio is saying that the future of cloud is confidential. And I will now add this Whisper model and open the connection to the OpenAI service, Azure OpenAI service. Is it stuck? Well, the demo gods are not with me today. You can't hear it because, it's right here. The future of cloud is confidential. So what it did is it took the MP3 file and it gave you that text out, right? So this is now something that enables you to use not just confidential GPU VMs, but also a PaaS service that is enabling confidentiality with Azure OpenAI ML service. So the next use case that I'm going to walk you through is Microsoft Cloud for Sovereignty. We have seen interest in confidential computing from a variety of regulated industries. But the one place that we see a ton of interest is from our sovereign government customers. And we have this offering for Microsoft Cloud for Sovereignty that is really an end-to-end offering with confidential computing as being a key part of it, with our key management service with Managed HSM, confidential ledger, but also several guardrails. Excuse me. And you get compliance and transparency. And really what you have is a fully ready to go landing zone environment for sovereign customers. This is something that is resonating a lot with our sovereign customers because it enables these sovereign landing zones, creates that baseline policies, provides transparency logs, enables these workload templates, and really provides that complete end-to-end solution for enabling these sovereign workloads to run in a additionally secured sort of environment, which gives them more assurance of end-to-end data protection. So now what are we doing for things looking forward? This is something that we announced a few months ago, Azure Integrated HSM. But what it does is it makes sure that there is a key cache in the hardware that is that is protecting the key on the node itself. The keys are isolated. They don't leave the HSM boundary. And the virtual machine has a local interface so that the keys are never really exposed in the virtual machine memory. We have already done a ton of work with Azure Managed HSM, which is a key protection service that itself runs in an enclave. And Azure Integrated HSM is the next sort of innovation in this space where we are doing further hardware innovation to protect your keys so that they don't leave the HSM boundary. It provides a high throughput key cache directly on the node where the confidential virtual machine can access. The other thing that we are also innovating is, we know that in a TEE, there's your code, there's your data, and then you access external services. How do you trust those external services? This is something that we've been looking into for a while with our transparency service. I don't know what we end up calling it, but how do you get transparency into the trust boundary? And what we're doing here is we are introducing these reproducible build receipts and ledgers into the confidential ledger integrated with our signing service. So when the cloud application creates that feed, there is an ingestion policy, and the auditor can now attest that the environment is set up in the way that they expect it to be. It provides transparency and something that enables that I know what is running in my cloud environment with additional services that I'm integrating with. This is something that is in something that we are thinking about for the future and something that we are working on. We hope to kind of bring it out soon. So that's sort of, a quick run around the block around, how has security evolved as we've been thinking about confidential computing over the last 10 plus years, some innovations that we're doing in this space. And now let's talk about, okay, who's actually using confidential computing and where do we see the interest coming from? Now, we all know that the current interest and the use cases are mostly around regulated industries, whether they are in retail, financial services, healthcare, sovereign services, and so on. At this moment, what we see is a lot of interest coming from these highly regulated, compliance driven industries and use cases. And at Microsoft, we believe in eating our own dog food. And we have, if you've not already heard it, you should look that up. But it's a cultural thing at Microsoft where we make our own services confidential as well. So it's our attestation service, the confidential ledger. I'll talk about the intra consumer and business in the next slide. We've been working with Google and across the space on the Bing ad selection API with the privacy sandbox. Our code signing service uses it. Our token signing service, I already talked about Azure OpenAI. And there's a lot more as well in our backlog that really doesn't fit on a slide, but we've been actively kind of making progress towards confidentiality. So this is Charlie Bell. He owns our Microsoft Security. And this is something that we've committed to, and we are well on our way, where we are protecting our identities and secrets by uh, running the infrastructure, the intra ID, inside the confidential computing environment and using managed HSMs. This is a great sort of use case because identity and intra ID are really mission critical services, and we are making sure that we can scale up to the demands and protect the most important thing, which are the secrets of an organization. The other thing that we've also been innovating with, and we've published a few items here, is privacy and ads APIs. Um, uh, this is working with sort of the privacy sandbox thing, with Google, and it 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 is yet another sort of step forward in protecting users from third party cookies and malicious content. We really know how critical uh, protecting user privacy is at this point, and I really feel that this is a massive step forward. And when you interact with Microsoft and you're giving us a credit card, that is going through a confidential computing environment as well right now. Right. So this is yet another service inside Microsoft that we are leveraging to protect consumer data. And we've been working with a bunch of customers. Royal Bank of Canada has been a customer for a while, with Swift, with Fireblocks, with Signal Messenger. There's multiple customers across multiple domains who we are interfacing with, and it's good to see the progress and maturity that we see from these customers. Sorry for the broken animation. But the other place that I mentioned earlier is Microsoft Cloud for Sovereignty. We've been working with multiple folks around Leonardo in Italy, Proximus in Belgium, G42 in UAE, and Korea Telecom in South Korea, where we see a bunch of interest around sovereign uh, use cases because, right, like there is a ton of sensitivity around how do we protect these sort of critical workloads end to end. This is where they see confidential computing as a key differentiator to add that additional defense and depth. We all know security is never really going to be 100%. It's always about adding more layers between you and the malicious actor. So to kind of close things up, when we say confidential cloud, what we mean is that the data is fully in control of the customer, end to end, from the time it is created until it's destroyed. The cloud provider, whether that's us as Azure or you as the service provider, is outside the trusted computing base. Code can be attested and verified. You don't have to take our word for it, or the service provider, or the ISV, or the entity that is providing you that service. You don't have to take their word for it. You can verify that trust. And the activity history itself is also immutable and auditable with the work that we've done with Confidential Ledger and what I talked about with the transparency service. There is much work ahead there. So, confidential computing is the future of computing. Clearly, the people in the crowd here would agree with that. But with that, I think I'm at time. I'll look at the chat messages. Thank you so much for your time.